In this video, we're going to go through the Math 150 to Statistical Methods 1 practice final exam. The actual final exam will be very close to what we're going to go through on here. We have 39 questions. The actual final will have 40. We'll talk about what that 40th question is when we go through these first 39. The questions will be in pretty much the same order, and they appear in the order that we covered the material in the course. So we're going chapter 1 and ending in chapter 10. There's a couple of questions that got a little bit out of order, but I'll identify those when we get there. Start with question 1. 49, 34, and 48 students are selected from the sophomore, junior, and senior classes. Those classes have 496, 348, 481 students respectively. So what type of sample is this? Random, stratified, systematic, cluster, or convenience? Since this is broken up into groups, it can't be a random. It also can't be a systematic. It could be a convenience, but we're picking a certain amount from each group, so that is going to be a stratified. If I had them broken up into groups and then I just took everybody from one group, that would be a cluster. Number 2, same directions as before. What type of sample is this? Is it a random sample, and is it a simple random sample? Psychology student wishes to investigate differences in political opinions between business majors and poli-sci majors. Select 100 students from 260 business majors and 100 students from the 180 poli-sci majors. Question 1. Is this a random sample? No, for the same reason that it wasn't a random sample for number 1. I had two groups. I had a group of poli-sci majors, I had a group of business majors. So no, it cannot be a random sample. If you're not a random sample, you can't be a simple random sample. So by default, this also has to be a no. How could it have been a yes and a yes? If all of these students were all put in together. So you went to a school and you looked at the total number of students, was that 440 students, and you went in and you picked 100 students just from the group. Is that a random sample? Yes, because everybody's mixed in together, and I'm pulling a random 100 students from that group. Is it a simple random? Yes, because I'm pulling 100, and I could wind up with 100 business majors. I could wind up with 100 poli-sci majors. I could have a little bit of each. Now, had it been 200 students total, then that would have had to be another no, because there's no way to talk to 200 poli-sci majors since there's only 180 of them. A good rule of thumb, if you're not really sure about a simple random sample, because I know it's a little confusing, it's helpful to have the same number of students in each group. A bigger thing is that you want whatever number that you're picking to be less than the total number of students in the smallest group. So 200 students wouldn't work because I only have 180 over here. Those are both from chapter 1. Number 3 is from chapter 2, which was all about graphs and frequency tables. How many households are included in this histogram? I have the number of TV sets, and then here's how many households have that. Well, I have 20, 50, what's that, 15, 10, and 5. So there's 100 households in the survey. So just 100. That's the only one from chapter 2. I got a bunch from chapter 3. Chapter 3 was about measures of center and variation. Number 4, you have 10 salaries earned, commissions earned from Tupperware sales. You want to find the mean. I won't go through it, but what you'll want to do is go into Stat Edit and type all those numbers in so that you can run one vars under Stat Calc, and then that will give you an X bar, and that will be your mean. Or you can patiently type all these 10 in and then divide by the 10 because you have 10 numbers. 5, we want to talk about a mode. A mode is the number that appears the most. There could be 1 mode, 2 modes, 10 modes, no mode. Here I have 1, 2, 3 6.6s and 1, 2, 3 6.3s. So this guy is bimodal because I have two modes. Had the 6 had that one not been in there, and there was only 6.6s and 3 6.3s, then it would just been one mode. Number 6, a student earns a C, a B, and an A. The corresponding credit hours are 4, 6, 1, and 6, and you're on a 4-point scale. So every A you earn gets you 4 quality points, a B is 3, C is 2, D is 1, F is a 0. Find your GPA. Well, I got a C, an A, a B, and an A. My credits for my class I got a C in was 4, 6 was the A, 1 was the B, and then that last 6 was also an A. We need to find the total number of quality points earned and then divide that by the total number of credit hours that we attempted. So we attempted 17 credit hours. We need to find, this is credit hours, how many quality points we earned. Well, for every C, I get 2. For an A, I get 4. And for a B, I get 3. So I'm going to need to multiply those quality points by the number of credit hours. So I have 8, 24, 3, and 24. So I earned a total of 59 quality points, and I took 17 credits. So my GPA is 3.47. This is a weighted mean. Weighted means all will have a total that you find up top, and then whatever your total number of points or total number of credit hours is what you divide by on the bottom. 7, coefficient of variation. I have 2 sets. I got heights and weights of teenage girls, and I want to talk about which one varies more. This is actually a pretty long question, so I'm going to bring all this data over to the Smart Notebook so we have a little bit more room. I am going to put heights in L1 and weights in L2. For a coefficient of variation, you need to find your standard deviation and divide that by x bar, and then you're going to eventually change that to a percent. The one that has the higher percent varies more. I'm going to go into Stat, Edit, move this over, and type in all these numbers. If you're not comfortable using the 2 lists, then you can do the 1 and then just go over to L1 again and type over the data set with the new data set that you want to find. All right, so now that's in. I'll say second mode to go to the main screen, Stat, Calc, 1 vars, and I get an X bar of 62.63. That's Holly. This is the coefficient for heights. 62 point something, 27. I think I said something else before. And standard deviation's 2.68. Let's find out what this is and change it to a percent, and I get 4.3. Now I'm going to find the coefficient of variation for the weight. I already have it in, so I'm going to say Stat, Calc, 1 vars, but I need it to go into L2. If you don't have it in L2, you'll need to go back, rewrite over L1, and rerun it. I get 18.31 and a 104.11. And that is going to give me, whoops, if I can get it typed in right, a much larger coefficient of variation, 17.59. 17.59. So weights vary more. You could also say that heights vary less. Either way is fine. Heights are more predictable, or you can say weights are less predictable. Either way is fine. The actual final will be multiple choice, so you won't have to pick a perspective. You'll just have to read it and pick the one that makes the most sense. Number 8 says use the empirical rule. The empirical rule was the 68, 95, 99.7 rule. If you're 1 standard deviation above or below the mean, 68% of the data lands in there. Plus or minus 2 standard deviations is 95, and plus or minus 3 standard deviations is a 99.7. Now you could find the z-scores because we're much further along in this material, and you know how to find a z-score and use normal CDF. But since it says specifically empirical rule, it means you're going to get nice z-score so that you don't have to worry about too much. This is how I approach these problems. I have a mean of 51, and my standard deviation is 11. So how many steps do I have to take down to get to 18? Well, if I go down 1 standard deviation, that will get me to 40. Another one will get me to 29. And then 1 more. So 3 standard deviations down, that gets me to the 18. So I'm at a -3 that way. If I add 3 standard deviations up and add the 33, then I'm going to get 84. And so I'm talking about being 3 standard deviations above or below the mean. And so that's going to be a 99.7. Number 9, also from chapter 3, number of pounds of sugar consumed per person has a mean of 4 and a standard deviation of 2. Tyler had 12 pounds of sugar. So how many standard deviations from the mean is that? Well, you could do it the same way as before, or you can remember that your z-score is x minus x bar divided by s. Tyler had 12, that's x. The mean is 4. Divide by 2, so 12 minus 4 is 8, and 8 divided by 2 is 4. So he is 4 standard deviations from the mean, and he's actually going to be above because it's a positive 4. If it was a negative, then he'd be below. Last one from chapter 3 is our box plot. Easiest way to do a box plot is to patiently type all of these into your stat edit so that they're all in L1. And then after you run this, I'm not going to change it just to save us some time on here. You would type all of these in L1. When you run OneVars, scroll to the bottom and you want from min to max. That's your 5-number summary, and that's what creates your box plot. So it looks something like this, where here's your min, up here will be your max. Here's the median. That's Q1, and that's Q3. And you'll just have to pick it because it's multiple choice. You won't have to worry about drawing it and making it look nice. And that's the end of chapter 3. So the first 11-ish questions are going to be from that first test from chapters 1, 2, and 3. The next about 11 or so will be from the chapter 4, 5, 6 test. So let's start with chapter 4. Number 11. Of 67 people who said yes to a question, 11 were male. So I'm going to start it out like this. Of people who said yes to a question, actually, let me change it this way. Let me say people who said yes to a question, there were 67 of them. 11 were male. Of the people who said no to the question, there were 44 people that said no, and 7 were male. So here's my no. 7 were male. There was 44. What's the probability that if you have everybody's name and their answer put in the hat, that you pull out a piece of paper that says either that they're male or that they said yes? So you could be a female that said yes. You could be a male that said no. It's either got to have a yes on it or male. It could have both, but it's just got to have one of each. So we got to figure out how many pieces of paper we have all together. Well, if 67 people said yes and 11 were male, 56 were female. 44 said no, 7 were male, so 37 were female. So I got 18 males that I talked to, many more females, 93, and I had 111 slips of paper for everybody that I spoke to. So 111 little pieces of paper in the bag. If you were said yes, so these are the people that said yes, or you were male, here's the people who were male. Now I circled this 11 twice, but I don't need to add it in twice, right? Those are my double voters. So this is kind of like the deck of cards situation where it's like I want a queen or a heart, but I might get both at the same time, but that doesn't mean you count them twice. So I'm just going to basically add the 18 that I have for the males and then the 56 for the females. And I get 18 plus 56, which is 74, over a 111. And again, it'll all be multiple choice, so it'll tell you how it wants it written, but the key says 0.667. And so that would be number 11. Number 12, adults in one town, there's a 60% of adults in a town have health insurance. What's the probability you talk to 8 adults and they all have health insurance? So you want a very long if-then, right? So I want to say this one and then another and then another and then another, right? So you basically want 8 yeses like this. A yes and then a yes and then a yes and then a yes, right? All these yeses. Well, the probability that you say yes is 60%, but I want that 8 times. And these are going to be independent because one person can have health insurance and the other person may not. So you don't have to worry about any kind of overlap. And so I can say 0.68 times, or I can say 0.6 to the 8th power. And I get 0.017. IRS randomly selects 3 tax returns from 51. Of the 51, 13 have errors. What's the probability that without replacement, none of the ones that you pick have errors? So you want to no, no, no. Well, you go into the bag that has 51 names. 13 have errors, so that means 38 don't. So the probability that you go in and you pick somebody's return and they don't have an error on the first pick is 38 out of 51, but then you keep it, right, because this is without replacement. So, and then when you go to get another one, there's not 51 in there, there's only 50. And you kept one that didn't have the error, so that's 37. And then when you go for your third, well, you pick the first 2 out, so now there's only 49, and the top is 36. So unlike this one where these were all independent, this is dependent. Each time my sample space is going to go down. So 38 over 51 times 37 over 50 times 36 over 49. And I get 4051. 4051. Couple more from chapter 4. Library is to be given 5 books. You're choosing from 15 titles. How many possible combinations are there? Well, since it doesn't matter how, which book you donate first, this is going to be a combination. So of the 15, I'm going to pick 5, but the order that they go in the bag doesn't matter. So I have 15 math over to probability and then pick number 3. So you got 3,003 ways that you can order the 5 books out of the 15 where the order doesn't matter. You don't care about the order. Number 11, order does matter because first I'm going to pick a chair, and then I'm going to pick a secretary, and then I'm going to pick a treasurer. And then if order matters, that's a permutation. So of the 11, I'm going to pick 3, but order is important. So now I have 11 math over to probability, and now I need to pick number 2. If order is important, you want a P. That's a permutation. If it's a combination, order doesn't matter. Pick 3, 990. Number 16 is actually one that snuck in from chapter 1. Height of a 2-year-old maple is 28.3. Is it discrete or continuous? This guy is continuous. If you can have half of something, it is continuous. Discrete is like for people or stuff you can't have half of. And we deal with a lot of discrete data in stats, but this is not one of them. Number 17 snuck in from chapter 5, so I'm going to skip that for a second and finish 18 and 19 because those are both from chapter 4. Two fair six-sided die are rolled. What's the probability you roll a sum of a 2? Well, this is that chapter 4A lab. You have 6 things that can happen on the first and 6 things that can happen on the second roll, so there's 36 things in your sample space. The 36 sums are not unique. Some of them duplicate, right? Like 7 is the most. That can occur 6 different ways, but a sum of a 2, the only way you get that is a 1 and a 1. So this is going to be only 1 because there's only one way to get a 2, a 1, and a 1. Now, if you wanted like a 3, then you can have a 1 and a 2. You can have a 2 and then a 1. So that would be 2. So check out that theoretical probability from the chapter 4A lab. Deck of cards on 19, last one from chapter 4. You want a 10 and then a jack. So probability of picking out a 10 is 4 out of 52, but this one's a little sneaky because it says with replacement. So you pull it and then you look at it, but then you put it back in. So this is not going to be 4 out of 51. This is going to stay 4 out of 52 because you put that card back in. So I'm talking about 4 over 52 squared. And if I hit math, enter, enter, it will reduce that fraction for me, and I get 1 over 169. I'm going to go back up to number 17 because that's where chapter 5 starts. It says, is this a probability distribution? If not, tell me what the problem is. In order for a table to be a probability distribution, the P of X is, right? All those probabilities have to add up to exactly 1. If I add all these up, I do not get a 1. So since this does not equal a 1, right? 0.977? Yep, it is not a 1. This is not a probability distribution. It's just some random frequency table that we have. And that is the requirement that's not satisfied. That is the only requirement that a probability distribution has. So you're either 1 or you're not. If we skip to 20, we'll do a couple more from chapter 5. Number 20, 70% of adults have a college degree. I have this table that talks about the probability distribution for the number of adults. If I pick 4, find the mean. So, chapter 5 was the only time that we had to link our list because our lists were not really just lists, they actually represented a table. So when you put these all in, you could still run one vars to find the mean, but when you do that, you have to say that your list is L1, which is probably there by default if you have a newer version of the calculator. Old calculator, you need to hit comma and then second L2. The newer calculators where it says frequency, you have to put in L2. And once you link it, you'll be able to get your X bar, 2.86. You'll need to do the same thing for number 21, although now we want to find the standard deviation. I'm going to skip this process of changing these numbers since you know how to put numbers in your calculator. You would do the same exact thing just with a different list, and then notice there's no S of X. You won't have an S of X, a standard deviation, a sample standard deviation for these. That's the only time that you use sigma. The only time you use sigma is when there's no S. That's it. That's the only time. This particular question had a sigma of 2 when you were done rounding. 22. 13% of people are left-handed. 6 people are selected at random. What's the probability that exactly 2 of them are left-handed? If you hear an exactly, you want to use binom PDF. The first number that goes in is N. That is the number of people. P is your probability of success. That's a 13, and then the number that you're looking for is the exactly 2. This is under second vars, our distribution menu. And I'm going to scoot down to binom PDF and type that in. and I'll get 1452. The only time you use a CDF is if you need to add a bunch of probabilities up from 0. So like, let's say you wanted less than 2, so you would want 0 and 1. So you would say, put in a 1, and then that would give you the combined probability of less than 2. If you wanted to know 2 or less, then you would put the 2 in, because CDF adds from 0 up to the number that you put in there, including that number for those probabilities. 23 and will be 24 will use the formulas that are on that formula card. Probability a person has an immunity to a disease is 0.4. You take a sample of 22 people, find the mean. Mean is just n times p. And so 0.4 times 22, and you'll get an 8.8. If I want to find the standard deviation, that's the square root of n times p times q. N in this question is 19. Probability of success is 0.7, so that means failure's got to be a 0.3. And then we just type this in the calculator. And don't forget to take the square root. And I get, well, when this all rounds, that's a 2. Oh, maybe the other one wasn't a 2 because this is a 2. And that's the end of chapter 5. Now we're going into chapter 6, and you'll know you're in chapter 6 because it will say normal distribution. The mean is 137 and the standard deviation is 5.3. Find the probability that you're between 134.4 and a 40.1. No story, just straight to the numbers. I have 134.4 and a 140.1, and I want to know the probability if I throw a dart at my bump that I land in the middle, but I'm going to need to change these over to z-scores. So the z-score for 134 is 134.4, subtract the 137, divide by 5.3. And I get a negative 0.49. For the 140, it's 140.1 minus the 137, divide by 5.3, and I get 0.58. And I will write that on here. Now I want to find out what's the probability that I land between them. That's normal CDF. Always CDF for normal. You don't. PDF is actually not a real thing. I'm not entirely sure why it's in there. Second vars, normal CDF, negative 0.49 to the positive 0.58. If you have a new calculator, there's a bunch of other things floating around in there. Do not mess with them. Leave mu as 0 and sigma as 1. 40, technically this should round to a 407. I know the key has it incorrectly listed as a 40.69. That's okay. 26, scores on the test are normally distributed with a mean of 68.9, a standard deviation of 11.6. Find P81. So you want to find the probability that you land in the 81st percentile, also known as the top 19%. So this is like those question 5s from the SAT lab quiz, where you first need to find out, well, where do I draw this wall that I split up the graph into bottom 81 and a top 19? Calculator only looks to the left for inverse norm, so I go second vars inverse norm and put in the 0.81, and I'm going to get a z-score of 0.88. Now if you put it in backwards and you just kind of forget and you say inverse norm of 0.19, you'll get the reciprocal. Now if you're past 50% to the right, 81's further along the graph than 0.5, then it has to be a positive z-score because the split for your z-score is at 50-50 for that 0. So I got a 0.88, and there's a rewrite of the z-score formula on the fold-out card. X, the number that you would have to get on the test, is going to be the mean plus the standard deviation times that z-score that you just found. So I would need to say 68.9 plus 0.88 times 11.6. 79.11. Then for some reason there's two central limit theorem questions on here. I don't really know why, so I'm just going to do the one. And I'm going to do number 29 since they're pretty similar. 326 randomly selected med students. Oh, actually, let me back up. I lied to you. There are two, but it's 27 and 28, and I'm going to do 27. I put that answer in the wrong spot. There we go. So let's do 27, and I'll show you what you would want to do for 28, but we won't go through the question to save some time. Annual precipitation amounts for mountain range are normally distributed. There's a mean of 85 and a standard deviation of 14. So it's a probability that the mean annual precipitation during 49 randomly picked years will be less than 87.8. So this is the bunny story, right? So you remember the video, all the little bunnies were on the scale, and then we found their mean weight. Same idea. I got all of the snow, I pack it somehow all onto a scale and I divide by 49. What's the probability that that mean for that particular sample is less than the 87.8? So I need to find the z-score so that I can say from negative infinity up to that. The z-score changes just a tiny bit. It's still x minus x bar up top. But my denominator is not just s, it's s divided by the square root of n, which is your multi-pick. How many years did you pick? So x is 85 minus, nope, x is 87.8, and mean is 85. S is 14, and I'm going to divide by the square root of n, which was 49, which works out well because the square root of 49 is 7, and 14 divided by 7 is 2. And up top I have a 2.8, so I have a z-score of a 1.4. They don't all work out that nice. So now that you've changed how you found that z-score, you do the exact same thing with the area as before, where you're going to say normal CDF, second vars, second pick, negative 9999, since I'm talking about like the smallest amount of snow possible, up to the 1.4, and I get 9192. On 28, you would do the same thing. Your mean is 53 and standard deviation is 5. N would be 90, and you want to know that you will have at least a mean of 53.527. So you would say whatever the z-score is for the 53.527 up to positive infinity. Since you want at least that, that means you want that or bigger. That's the end of chapter 6. Which means we're going into 7 and 8, so we're almost done. You can see we're at question number 29. And this is all about confidence intervals. So I have a 95% confidence interval for the true population proportion. Of the 326 randomly selected medical students, 29 said they plan to work in a rural community. So 95% confidence interval, so you know you're running something hopefully in the calculator that ends with an int. And the next question after, test the claim and confidence interval should be for what, right? Because you got 3 unbiased estimators: proportion, mean, and standard deviation. And this is for proportion, so that's a 1 prop z. And it's an interval, so it's a 1 prop z int. All of our formulas and programs for confidence intervals and hypothesis testing will be in stat over in tests. Tests come first, so I'm going to need to scoot down so I can find a 1 prop z int, right? And for me, it's A. And I had 29 of the 326 say that they're going to work in a rural area, and I want a 95%. That's my sea level. And it should come up pretty quickly. So 058, that should be a 1, 2, 058, and a 0.12. Number 30 is a little strange. Research is interested in estimating the proportion of voters who favor a tax on e-commerce. Based on a sample of 220 people, she obtains the following 99% confidence interval for the population proportion. And there it is. What does this mean? So you need a very fancy sentence. And I'm going to attempt to type it. If many different samples of size 220 were selected, and a 99% confidence interval was found. In the long run, that's important, you can be, run out of space, I'm going to come down here, 99% confident that the true population proportion is contained in the interval. That's what you're looking for. It has to be that you're doing them all the same size. They all run the same confidence level. And in the long run, right, so you're not going to do like 10 of these. You're going to do a lot, whatever a lot is. In the long run, you'll be able to be 99% confident that the true population proportion is contained in the interval. That's pretty, you don't know which 99%. There's going to be some that are too high, some that are too low, but that's as best as you're going to, good as it's going to get. And I'm going to get this out of the way because it looks messy. 31, Savings and Loan Association needs information about checking accounts. You got a random sample of 14. That had a mean balance of 664.14 and a standard deviation of 297.29. Find a 98% confidence interval for the true mean account balance for local customers. Now, this is a random sample. This was the mean and the standard deviation just for the sample. So when you have a confidence interval for the mean, you have to say, is it a Z or a T? If you know sigma, then it's a Z. If there's no sigma, you only have S, like what we have here, that's a T, right? You only have sample. So I need to go into stat, test, T interval. I have the stats, 664.14. Standard deviation was 297.29. I had 14, and I want a 98. Takes a little bit longer for these to come up. And that's my confidence interval, 454-ish to 875-ish. If I had given you the 14 account balances and then said figure it out, when you went into here, you would have actually wanted to scoot this guy over to data, and you would want to put those 14 pieces in first. 32, and our last question for Chapter 7. Find the standard deviation for the diameter of wood dowels. The manufacturer measures 19 of them. He finds the standard deviation of the 19 to be 0.16. Find a 95% confidence interval for the population standard deviation, which is a little sad because you cannot do that in the calculator. So, back over here. I want to find a 95%, which means I have 95% of the data in here. And I'm going to need to find out where to put these bars up. Outside is 5%, an equal amount on both sides. So just divide that by 2. My formula is n minus 1, that's the df, times s squared. And that's going to be the same on both sides of this inequality. That sets up our interval. But our denominators, so this is my left one, and this is my right one. But they are going to flip-flop when they come in here. And finding those is the worst part. So I had n equal to 19. That means df is 18. And that formula card reads backwards in that I'm going to say the area to the right. So the area to the right of this left one is that 0.95 plus this little bit. That's 0.975. So I'm going to go to the fold-out card and go to the very last one. And I have, here's the 997, and I got to go down to 18, and my left is 8.231. Now I need to find my right. Well, that area is just the 025. Still has that same DF, and that's this column right here, and that's 31,526. Now I can go ahead and plug everything in. This is going to be 18 times 0.16 squared. The 31.526 will come this way. Same numerator. But over on here I'll have the 8.231. Now you just need to plug this into your calculator. Do not forget to take the square root. The formula card does not have the square root listed. Make sure you take the square root. You want sigma, not sigma squared. So everything needs to have the square root taken. I'm not going to type this in. You know how to type stuff into your calculator, so to save some time, you can go ahead and find those numbers and make sure they match what's on the back of the page. 35 is your other weird question. I have a null that is p greater than 0.649, which means my alternate has to be p equal to 0.649. Null always has the equal. I got a test stat of 134. Now this is a right tail test. We know that from the greater than. So what I need to find out is what's the area under the curve from the 134 up to positive infinity, because you go to the infinity that it matches. It uses a 0.05 significance level. So if my p-value is less than that, the area under the curve, I will reject the null. If it's bigger, I'll fail to reject. And it's way bigger, right? So the p-value is 0.091, 0.0901, sorry. And this is going to be fail to reject, because that p-value is much larger than the 0.09. That's all you need to do for that one. I know it's a little weird. Hang in there, about 10 more minutes, we're almost done. 34, sample of 167 children. 37 have asthma at a 0.05 significance level. Test the claim, that's where you get your pen ready, that the proportion, that's P, of all the children in town who suffer from asthma is, that means equal, is 0.11. That's my claim, that's also my null, which means my alternate has to be the not equal. The good news, this is for the proportion. Proportion's 1 prop z, and I want to check the test, so I'm going to say stat test 1 prop z test. That p not in there, you're going to match what's in your null. You have 37 out of the 167, and then I need to match this, so that's an equal to. I'm going to use draw because I'll get less information that way. I'll get only what I need. I'm going to look for my p-value. P-value is 0. Well, that's certainly less than 0.05, so I'm going to reject the null, which is bad news. My claim was my null, so I need to go to this chart. If your claim is your null, so you've starred H naught, then you go this way. If you've starred H sub 1, then you go this way. So did the original claim contain the equality? Yes. Did I reject it? Yes. There is sufficient evidence to warrant the rejection of the claim, and that is the answer choice that you're going to have to pick. All of this other stuff is not going to be in the question. You're going to have to pick only the magic sentence to get credit. Okay, next question. Test of sobriety involves measuring subjects' motor skills. 20 randomly selected sober subjects take the test. They have a mean score of 41 and a standard deviation of 3.7. At a 0.01 significance level, test the claim. So get your pen ready that the mean, that's mu, for all sober subjects is equal to, so equal to is equal to 35. That's my claim. That's my null again, which means my alternate is mu not equal to 35. The good news is mean can be done in the calculator, but you have to say, do I want a P, Z or a T? You don't know something about all of the sober people in the world, right? You only know about these 20, so this is going to be a T test. So I'm going to go into stat, test, t-test. I have the stats. I don't have the data, right? It would be different if they said, hey, here are the 35 or the 20 scores, and then you'd have to put them into L1 and scoot over the data. I don't have that. I'm just going to match my stats. In the null, it's a 35. The mean was a 41, and the standard deviation is being covered, 3.7. I had 3.7. There we go. I had 20 people in the study, and I need to match it. That's still a not equal to, so draw. T-test and t-intervals take much longer to draw and calculate, but I believe this was another 0. Yep, p is 0. That's less than 0.01. So I got another reject the null. And I'm going to follow the same format, right? So reject the null, yes, because my claim was the equality, and I rejected it. So again, there's sufficient evidence to warrant the rejection of the claim. On the real test, do not assume that because we did reject the null that it's got to be reject the null over here. 36. 12 bolts are tested for hardness, and their standard deviation is a 41.7. That's S. Test the claim. Okay. Got your pen ready? This is standard deviation. That's sigma of the hardness indexes for all the bolts is greater than 30. And that's my claim. And it's also my alternate because it's got the greater than symbol. The null always has the equal to. But I can't do this in my calculator. I have to do this by hand. So I want a greater than. So I have a right tail test, and my sigma was a 0.25. And what I need to do is figure out what my test stat is. The test stat is my DF, which was 11, right? Yeah, 11, times my S squared, which was a 41.7, over my claim, which was 30 squared. And I'm going to need to figure out what this value is. 11 times 41.7 squared divided by 30 squared, which is 900. And I get a 21, I'll just say 25. Now, I don't know if it's on this side or if it is on this side, because the chi values are not symmetric. They don't start at a negative infinity, right? There's not a 0 in the middle. I start at 0 and I go up, so I really have no idea what's going on here. All I know is that this is a 21.25. So the question is the area under the curve more than this 0.025? Does it spill over into the fail to reject the null? So to find the p-value, I'm going to have to go into second vars, but this is for chi squared. So I'm going to have to say chi squared CDF, and it's test to tail. So this is a right tail test, so I'm going from the test stat to infinity, because that's the tail. Had this been a left tail test, it would have been 0 to the test stat, because they don't have a negative infinity. But you got to stick the DF in. DF was 11. P-value is 0.0308, so I do overflow. So I have a reject the null, which is actually good news. So I have now, did the claim contain the equality? No, because my claim was that it was greater than, and did you reject the null? Yes. So the sample data supports the claim. That's what I would have to pick. All that other extra stuff is not going to be on the test for you to choose. You know, you have to calculate it to find the answer, but not it won't be there for you to like weed out the correct answers. And that's the end of chapter 8. I got 3 from chapter 10. Find the linear correlation. X goes into L1, Y goes into L2. And I'm going to cheat a little bit, and I'm not going to like quite do the second question. Stat edit, I'm going to clear this out. Make sure when you're clearing these list out that you still have an L1 and L2 in there, because the calculator defaults to those, and it will work in other ones, but you have to remember to tell it where to go. So if your L1 and L2 disappear during the test, let me know and I can get them back for you. Just make sure that they're there. Also make sure that when you enter these data pieces that they're with their buddies, right? The way we're going to run this is that they know that this is how it's linked as a table, right? There's a couple of different ways that you can find a linear correlation. Since we have a couple of things that we wanted to do in 10, I always ran a line reg t-test, stat, test, all the way down to, oh, there he goes, line reg t. Good news is you can leave all of this stuff alone. L1 and L2 should be X and Y. Frequency should be a 1. We always want this to be a not equal to. Don't worry about the reg equation because we're not going to graph it. All I have to do is hit calculate. And I'm going to scoot down to R, and there's my R, right? So 109.109. That's all that we wanted for 37. Now 38, all you want is the regression equation, and I'm going to save some time by not typing in new numbers. But your regression equation is Y equals the A value that pops up when you do the line reg t plus B times the X. So A and B come out, those numbers go in, but the Y and X are part of the question. So that's what you would do for 38, and it would look something like some number plus or minus some number times X. But I'm not going to run it to save some time. Last question. Yay, right? Regression equation relating attitude, that's your X, that's your input. And job performance rating, that's Y, that's the output. You get this Y hat, 11.7 plus a 1.02X, right? So that's the regression equation that we were talking about up here. 10 pairs of data, so N is 10, were used to get that equation, and it yielded a correlation of 0.863. And by the way, Y bar, so if all the job performance rating for those 10 people, that mean job performance rating was a 80.1. So if I had somebody that had an attitude rating of 56, what's your best guess about what their job performance is? So what you need to do is say, well, can I give them a quote that is based specifically on the 56 using this regression line, or do I have to just default to the 80.1 because I don't know enough about it? I need to go to one more chart. It's A5 or A6. It really kind of depends on the version that you're using here, but it will say Pearson correlation coefficient. I merged a couple of words there, right? So N is the pairs of data, that's 10. And it didn't say which one to use, so you use the most restrictive, that's a 0.01. And in order for you to say that there's a linear correlation, it would have had to have been better than a 765. Good news. We have greater than a 765, right? We got an 863. Ooh, that's Holly again. That means that this line is good, right? That means if there is a linear correlation, there is a linear relationship, which means the linear regression line that we got out can actually be used for something. So if I want to know what my best guess is for a 56, I can actually type that in and swap out the X and put in the 56. And the best predicted job performance rating, if you have a 56 attitude, is about a 69 job performance. Had this R not been greater than the 765, then let's say it was a 563, that means there isn't a linear correlation. There might be some kind of correlation, but it's not linear, which means that would be junk. So calculator is always going to give you a line. It doesn't mean that it's really any good for anything. When that's the case, then you'd have to use Y bar. 40th question is either what you need to be a binomial distribution. Binomial distribution. But I always put an extra binomial distribution. That's like 5.2. Or what you need to be a normal distribution. And that's 6.2. There's a slide. The binomial's got like 3 or 4, and so does the normal distribution. It has like 3 or 4 things on it. You could pull that up from the Chapter 5 or Chapter 6 PowerPoints. That's your 40th question. Your real test will be very much like this. You'll have 2.5 hours, but it won't take you that long. And I will see you very soon.